Okay, in this video we're going to talk about fraction division. And we did with fraction multiplication, I'm going to show you how to actually do it, and then we'll see why that works. But before we get into that, I have to introduce this concept of a reciprocal. And reciprocal means something really simple. It means if you have a fraction, like just make one up, 3/4, it says when you take the reciprocal, taking the reciprocal just means you take the 4, which is in the denominator, put it up in the numerator position, and take the 3, which is in the numerator, and put it in the denominator position. So it literally says if you have a fraction, like, I don't know, 1/2, says flip it. Flip the places. So 1/2 would give you, the reciprocal of 1/2 would give you 2/1. Which just actually happens to be 2/1 can be written as just like 2. It's a whole number, right? Any number divided by 1 can be expressed as that, the number divided by 1, like that fraction, or you could just write it as a whole number. Okay, so now that we have that idea of what a reciprocal is, and I'll show you exactly how to mathematically figure out how to take a reciprocal, like some operation. Here I'm just showing you what it is. I didn't show you the operation necessarily. But now we can quickly see how to do fraction division. So if we have a fraction like, let's say 1/2, and it is being divided by 3/4, the way you do, oh, by the way, this is called a compound fraction. So when you have a fraction divided by another fraction, we call it a compound fraction. I mean, it's like fractions within a fraction, right? And so it's kind of like Inception, right? A dream within a dream, fraction within a fraction. So anyways, the way you do this is you take the entire fraction that's in the numerator position. See, and notice, by the way, this fraction bar here is longer, it's bigger, and which usually is like denoting that, hey, this is the 1/2 up here. This little guy is being divided by this other little guy. So this is kind of like the big bar shows you like the real division symbol between the two. So anyways, you take this and you put it just as it is out front. But then you multiply by the entire denominator's reciprocal. So you multiply it by, this is 3/4, the reciprocal of that would be 4/3. And then you just go ahead and multiply it as usual. We can see that we can cancel here, cross cancel 2 and 4 because they share a common factor of 2. So we can have a 1 there, right? Because 2 goes into itself once, it goes into 4 twice. We see we got 1 times 2 up top gives us 2. 1 times 3 on the bottom gives us 3. And we see that 1/2 divided by 3/4 gives us 2/3. Okay, let me show you another example with compound fractions. What if you had something like 5, but it's being divided by 2/7? Is this a compound fraction? You might be inclined to say no because you're like, oh, the 5's not a fraction. But actually, it is. Any whole number is a fraction where you can write a 1 in the denominator. And so we do regular fraction division. You say, oh, put that there, 5/1, be multiplied by the reciprocal of 2/7 is 7/2. And we see that this is equal to 5 times 7 gives us 35. 1 times 2 gives us 2, so it's 35/2. Okay, well, what if we had the other situation? So what if we had, 5/6 over 7? Is this a compound fraction? It is. It's the same deal. If you have a whole number somewhere, just write it over 1, and then you can do it. So you have 5/6 comes out front, and then you multiply by the reciprocal of 7/1, which is 1/7. And we get no cross cancellation being able to happen, so we just do 5 times 1 is 5. 6 times 7 is 42. We have 5/42. So those are some examples. And now I want to show you actually how you could even figure that out, right? Because I'm just showing you this is how you do it. But you might be wondering, like, where did you get that procedure? Did you just pull that out of thin air? And the answer is no. It's a real procedure, and gives you the real answer. We use this procedure to solve real problems all the time, and they give us answers at work. So how did this? Whoever figured this out? Like, how did they figure that out? So I don't know for a fact because I wasn't there, but I have an idea that maybe they took. So let's just give ourselves a fraction to look at. So maybe like something like a half. And this is a little sideways bar, but it's the same as if it was a horizontal bar. It doesn't matter. I'm just doing that to make it more squished down and not taking up so much space. So what if we had half divided by 3/4? And let's say we didn't know how to do fraction division. How could we figure that out? Well, let's say we did know what fractions were, and we did know how to do fraction multiplication. We just didn't know how to do the division yet. One thing, if we were really creative, we might say, okay, let's try to turn this into something we actually know what to do with, because we don't know what to do with this. Why don't we take this 1/2, the entire thing in this numerator, and substitute it with some symbol? So why don't we say let some letter A equal 1/2? And let's do the same thing with this entire denominator. So why don't we say let B equal 3/4? If we do that, then we can come back to this fraction and say, well, 1/2 is equal to A is equal to 1/2. That means I could put an A in the position of where the 1/2 is. And when I say A is equal to 1/2, so I'm saying for this particular problem that we're doing, that's not some intrinsic value of A that it always equals that. No. This is just for this problem where we're letting A equal 1/2. So we can put it in place wherever we see a 1/2. And the same thing with B. We have a 3/4 here. We said B is equal to 3/4 in this problem, so we're going to put a B down there. Now this looks like just some quantity over some other quantity, like any normal fraction we're used to. But where can we go from here? Well, not far, unless we get creative. And in math, a lot of times you have to get creative, and you have to recognize that there's something very special with the number 1. Because you can always think of any number being multiplied by 1 if you want to, because multiplying by 1 doesn't change the value. If it doesn't change the value, you can do it as much as you want and you're not changing anything. But we'll see that if you do it, it could actually help you. This is a weird thing. This is about math. It's like you're doing something that literally does nothing to the value in the end, but doing so actually makes problems solvable. So if I think of A as just being A being multiplied by 1, and I think of B as like maybe 1 being multiplied by B like that, I know that this fraction can be split up because we know how to do fraction division, and we know we can sort of think about breaking the fraction up, right? And having A over 1 being multiplied by, actually I'm going to write it like this, just because I've been writing it like that. That little dot also means multiply, right? So A over 1 be multiplied by 1 over B. All I did was break this fraction up. And if we went in the forward direction, we kind of think about this, we went in the reverse direction. If we went in the forward direction, actually combined these two back, we would get that right there. Okay, I didn't mean to point to the equal sign, but to those numbers there, A over B. We don't want to do that because that's where we started. We want to actually get somewhere. But I'm just showing you that if you combine them, you get back to that. It means it's what we've done is allowed because we haven't changed anything. We're still going to get the same value we always had before if we try going back, in the backwards direction. So anyways, doing it this way leads to some interesting results because A over 1, well, anything divided by 1 is just itself. So sometimes it makes it easier for you to write it over 1. Sometimes we don't need the 1. So what I'm going to do is I'm going to say, well, that's just A. A divided by 1, well, that's just A. It's A times 1 over B. Okay. Now it looks like a 6, but it's a B. We said up here somewhere that, right here. A, I said, was equal to 1/2, right? Okay. Well, let's write it. A is 1/2 times 1 over B, which is 3/4. So we have 1/2 times 1 over 3/4. Now this is looking more like what I showed you how to do fraction division before, right? I said you take the numerator, whatever fraction is in the numerator, you just put it down there, and then you multiply. Well, we're multiplying here, but then I said you multiply it by the reciprocal of the thing in the denominator. Here we have 1 over 3/4. The reciprocal would be 4/3, not 1 over 3/4. But it just so happens that 1 over 3/4 is 4/3 when you actually go through and solve it. So I'm not just going to tell you that, I'm going to prove it to you. So it turns out, by the way, I told you earlier, like I didn't show you the process or the operation of taking a reciprocal, and it turns out this is it. And I'll show you here what I mean by that. So let's start with something a little easier before we get to the 3/4. So what if we had, here we had maybe just 1 divided by 1/2. Well, first, let's go easier still. Let's do, what does it mean when you have 1 divided by 2? First, let's look at that. 1 divided by 2. This is saying 1 divided by 3/4. I want to just say, what's 1 divided by a whole number? Well, geometrically, we've already done this. We can do it again. If we have a square, 1 square, and we divide it by 2, we are cutting it such that we have 2 equal parts. 1, 2, right? Okay, so far so good. But I don't want to divide by a whole number like 2. I want to divide by a fraction. So what if I divided it by 1/2? What does that mean? How do you divide by 1/2, right? When I was dividing by a whole number, I was breaking the square up, right, into pieces. But how do I cut something into something that's already supposed to be cut up? Well, there's only one other alternative, is to actually add on to the square. So actually what we need to do is divided by 1/2 is we need to make this 1/2 of something else. Well, what would it be 1/2 of? It would be 1/2 of 2 squares. So the 1 square we had is 1/2 of 2 squares. And so it turns out that when we divide by a fraction, we are actually adding to it. And so, and the answer to this, by the way, 1 divided by 1/2 is 2. And so we get 2 squares. It just so happens to work out like that. So what you're saying here, you know, if this doesn't make sense, look, if you started with the 2 squares and you multiplied it by the 1/2, right? We did this before. That would be like saying, okay, well, if you had 2 squares like this, right, and you multiplied it by 1/2, you're saying I want 1/2 2 times. Well, that's 1/2 plus 1/2. 1/2 plus 1/2, that's 2 halves. 2 halves simplifies to, they can both be divided by themselves once. So 2 goes into 2 one time each. So it's 1 over 1, that equals 1. So we have 1 of the original 2. And well, guess what? That just so happens to be 1/2 of what we started with, right? So 2 times 1/2 gives us the 1, okay, which is what we had up here, the 1/2. But then if we divide 1 by 1/2, it takes us back to the 2. So if this seems a little odd, right, let's think about it this way. So let's do whole numbers for a second. So if I multiply 2 by 4, that gives me 8. If I take 8 and I divide it by 4, that gives me the 2, right? That gives me this 2 right here. We see this is the relationship. Nothing is different from what we're doing right here. I'm saying right here, if I have 2 being multiplied by 1/2, it gives me 1. Okay, if I take the 1 and I divide it by 1/2, it gives me the 2, right? That's how it works. And look at what else we sort of proved without really thinking about it. We said 1 divided by 1/2 gives us 2. Well, let's look at this. 1/2, how is 1/2 related to 2? Well, 2 can be written as 2 over 1. Ah, they're reciprocals. So it turns out that 1 divided by some number means take the reciprocal of whatever number that is in the denominator. So if 1/2 is in the denominator, did I say that weird denominator? You flip it. So 1/2 gives you 2 over 1, which is 2. And so in this case, going back to the problem we were working on right here, we had 1 over 3/4. Well, the 1 is 1 divided by 3/4. That's telling you to take the reciprocal of the 3/4. So this turns out that it equals 1/2 times 4/3. And we already did this problem earlier. That's cancel, right? That gets 1, that's 2, and we say that that's 2/3. Okay, so what does that mean geometrically though, right? I kind of showed you some geometric stuff here. What does this mean though? I'm going to try my best to do it. It's not easy. So, okay, so we started with a half, right? So let's talk about squares again. We have a square, and we're starting with a half. So imagine the square is, this length of the square is 1, right? It's a 1 there, but we only have half of it, so one of these is shaded. And then we want to divide by 3/4, was it? Yeah, divided by 3/4. Okay, well, we can't cut this up anymore to 3/4, because if we were taking the 1/2 and then dividing it by 4, right, then that would be dividing it this way or however way. But we're not dividing it by a whole number, we're dividing by a fraction. So the only thing we can do is to think about dividing it, and I'm going to have to write this a little differently. So I'm going to say this is 1/2 divided by, ready for this? Instead of 3/4, I'm going to write it as 3 times 1/4. Okay. So the way that this ends up working out, then we can rewrite this as 1/2, right, divided by 3. Okay, so I'm gonna say, well, let me back up here so you can see what I'm gonna do here. I'm saying this is 1/2 times 1. Remember when I said sometimes it's actually to our benefit to write times 1, right? And then I'm going to say this is 1/2 over 3 times 1 over 1/4, like that. Okay, so what is 1/2 divided by 3? Now we know how to do that. We have 1/2. We're going to divide it into thirds, right? And when we do that, by the way, we need to divide all the way across. Okay, and so we see we have this sort of deal going on, right? So we end up with, if we had one of those, it'd be a 1/6, right? So anyways, then we're going to multiply it by, well, and oh, I should say this is, 1/6 is what you get when you do this part. When you do the 1/2 divided by 3, you get this 1/6, because you have a half, you divide it into thirds, right? And then you have to divide the whole thing, and you see you have 6 equally spaced slices, or not equally spaced, equally sized parts, and we have one of them. Okay, now we're going to be multiplying by 1 over 1/4. Well, I already said 1 divided by some number means take the reciprocal. So that's like saying to multiply by 4. This thing ends up just being a 4. So we multiply that by 4. So we're saying we have 4 1/6. So, well, all we have to do then is say we have 4 of these instead of just 1. And actually, I'm going to use a different color so that's clear. So here's the one we have, and we have another one, and we have another one, right? And we have another one. Okay, well, another way we can think about this, and actually maybe I should have filled it in slightly different just so that this is clear. Filled in this way. So there's 1, 2, 3, 4, right? Now, I told you the answer up here was 2/3, right? Well, look at this square. No, got shifted here. Here, you can think of this is 4/6, right? This could be 4/6, but you could think of this whole thing being a third right here, this whole block, and then this whole block being a third. And we have 2 of the thirds. So that's why that simplifies to 2/3. So I don't know if that was necessarily more helpful. It gets a little complicated when you're talking about fractions and trying to show it geometrically, and especially with the division going on. But we see geometrically that if you do it correctly, right, it shows up and you see that, yeah, we have 2/3 of the entire square. Okay, so that's how you do fraction division.